Okay, so now we'll start the battery discharge circuit. Last video we saw the same model. Okay, the same model, whatever is on the screen. Actually, in this case, we are charging the battery and we are stopping at 90%. Maybe I did by 80%, so it is same actually. So now we have to go for the 90%. Okay, no, we are not going for charging. Actually, we are now going for the discharging circuit. So for discharging circuit, okay, what are the things that I have to replace? Just see on the screen. It's very normal, right? So when you are charging, the flow of current is from DC voltage source to battery pack. Correct? No. But when I will be discharging, okay, the power flow, or you can say the current flow, will be from the battery to the load. So actually, I have to replace this DC voltage source with the load. Am I correct? So take a series RLC branch. Actually, it's a resistive inductance and capacitive load. I have to make as a resistance. Why? Because I want to give only R as a load. See, if you double click on this, you can check R, L, C. If you want, you can give any type of load. I want to give R as a load. Press apply and OK. You can give some value to the R, but as of now, leave to 1. So now just name it as a load. Press on this block, press Ctrl R to rotate. Why? Because I want to keep it vertical. See, it's connected. Upside is connected, bottom side is still red, so you have to connect negative to negative. Now the flow of power is from the battery to load. Correct. So what I have to change, my agenda is to stop the battery discharging at 20%. Just reverse of the previous video charging case. So what you can do, just reverse this one, make them greater than equal, right, and change it to 20 because I want to stop the discharging at 20%. Simple. Can you check now the model? Rest everything will remain same. Okay, but actually in real time I'll be not using this load. I mean to say in real time we will have some machine as a load. Correct now. In electric vehicle, what is the load? To battery pack machine. That machine may be a DC motor, AC motor. It may be the switch electrons motor. So motor is the load. Okay, so as of now I took as a resistance as a load. If you want, you can take DC machine also. That I will be discussing in some other videos. Okay, as we are just seeing the basic of the simulation. So once our hands are set, okay, then we will go for the big modeling. So stay tuned for the big modeling. By the time you all can set your hands, okay, please follow from scratch. You will learn the complete electric vehicle design. Spend follow my videos, okay, on the day-to-day basis. Yes, this DC machine you can take as a load. See, right. Go and check the show block. Instead of this load, I can connect the DC motor as a load. Okay, but I am not doing right now. Okay, just let me know how to connect this via comment box. I'll be happy to see the comment. Okay, so delete this one. Select and delete from keyboard. So what will happen if I run this motor now? I'll be getting the battery discharging. Why? Because load is connected. And at what time I have to stop? 20%. Yeah, you check the initial SOC. What is the I kept is the 80. So from 80 to 20, then a flat line. A decreasing curve from 80 to 20, then a flat line is required. Stop time you can give, maybe start with 50 seconds. If it is not enough, we will increase the simulation time. Okay, just run it and you can see the scope. Okay, so when it initialize it, okay, when it shows ready, then only you are supposed to see the scope. Just click on a scope, you can see the battery discharging, right? Correct, no? The battery discharging, you can see here correctly from 80 to 76. You have to increase the simulation time, okay, because it is not sufficient. So maybe you give one hour. An hour is 3600 seconds, right? You can see here. See from 80 to 0 and then it is going. See, it should not go up to 0, right? It should not go up to 0 because I gave the instruction 20. But still it's going to 0, so we have to rectify the error. What may be the error? I think the MOSFET we have to reverse. Why? Because now the flow of power is in different direction. So how to do that? You know how to reverse. Just delete this line. Okay, press this Control I and now connect D to positive on battery S to the resistance. Why I reversed? Because last charging time it was in the reversed way. So now I again reversed so that the power flow is from the battery to load. Correct. So this is the way you have to little bit keep the logic with you so that you can see the up from 80 to 20 and then no further discharge. Earlier it was coming to 0, right? But this is correct. Why? Because I gave the instruction up to 20. See, this is the way how you can start your electric vehicle designing course. Okay, slowly you can set the your hands and then you can go for the big modeling. Okay, that means the complete BMS modeling, cell balancing modeling, active cell balancing modeling. A lot of things are yet to cover. Please stay tuned. Please like, subscribe, and also post a comment that why, how to connect a DC machine as a load. Okay, so that's all for this discharging circuit. Next video we'll be seeing some extra little bit more advanced. For example, we can go for the SOC estimation. Okay, please stay tuned. Okay.